Hi, this is Kumar Singh from Design Analytics LLC. Well, the Maverick idea that we are going to discuss today is around this news article. Right. Now, I shared it, I think, last week in one of the LinkedIn posts, and then I promised that we will go through what could be a best evaluation criteria, specifically focus on one of the tracks mentioned already in the article, right? The real world usefulness. Now let's keep aside the evaluation aspect for a minute, right? Why do any business exist, right? Most businesses, they exist to make money. Eventually, sooner or later, they will have to make money. That's the reality of capitalism, right? You can run away for it for a while, but eventually you will have to get there, because that's why investors are actually trying to invest in your product to get a return on that, right? So eventually you will have to develop a business model that earns you a lot of money, actually, in this case, because some of the valuations of some of these companies are huge, right? Now, that kind of business revenue is not going to come from the individual users or the general creative uses of these applications that's currently kind of more prevalent, I'll say. So it has to be eventually an enterprise AI path, right, where these models eventually get leveraged as part of solutions in enterprises, both public and private, right? So coming back to the track of usefulness, that is where the real evaluation criteria lies, right? So you want basically to evaluate the solutions in the real world, and the real world is the world of enterprise problems, challenges within enterprise. Now, every enterprise has a different set of challenges, right? So the gist here is, how do you define a standardized set of business problems, right? That is the challenge, and we will come to that. Let's pause this as well for a minute and get back into why scores on standardized tests, or like beating a human on a standardized test, is actually self-defeating for these models, right? Specifically after that paper from Apple, The Illusion of Intelligence, right? Because standardized tests are basically, they can be mastered if you know, if you have a knack for standardized tests, specifically tests that are administered in US, right? That do not change. They may change in format, as in number of questions may change, the structure may change, but the type of questions, right, they generally do not change. So if you can basically solve a large number of questions in each category, you get a hang of almost every possible type of question that you may come across in the exam. And that falls more within the realm of the memorization aspect of the model, right? So if a model memorizes every possible type of question, it will obviously score higher than a human who may not have the capacity or capability to memorize the entire question pool. So that is why it's not actually a good measure of how effective the model will be in the real world, because the very basic aspect of machine learning, not even AI, is generalization, right? Not memorization. So the reason Apple's paper Illusion of Intelligence wasn't exactly like accurate, it was accurate in terms of the methodology that LLMs use, but the generalization aspect of these models is what is kind of the illusion of intelligence, not the memorization, right? So that's the reason those standardized tests are not good benchmarks, right? If we come to the technical benchmarks, again, they are more geared towards the technical performance of the model, and that's the reason they are, again, not really good in terms of understanding the effectiveness, and the evaluation criteria at this point has to be focused on the real world applications. So coming back to our real world application, the key is to develop a set of problems, right? Now, there are many different angles to this. Each problem will fall into several different categories, like an intersection of these categories. So obviously it would be the difficulty level of the problem, like easy, intermediate, and hard. And then there would be the type of problem. So for example, in the context of planning, it could be tactical, operational, and strategic. And you can keep on kind of adding aspects to it and make it so fine-tuned so that you can develop a pool of questions, much like a standardized test, but very different from it, where the model actually gets challenged on something that it has not seen and not directly trained on, but it uses training in many different aspects to understand what can be solved. And it's not always about a planning algorithm or logic, right? So if you think, even if something really simple, like if you're making a churn prediction model, there are aspects beyond the algorithm where you have to deal with the data, right? What are the data sources? How do we basically collate the data into one cohesive view, do initial business intelligence, data validation, things like that, even before you start building the model. And that's kind of a problem that I'm describing that would fall into the easy problems category, but that's just an example. The powerful aspect here is that if you can develop a pool, market that pool, explain that pool properly, so that organizations, enterprises see that pool as a good test, as a real test of an AI or a model's capability, then they will be interested. They will be really interested in using that as the benchmark for effectiveness of an AI model. And that kind of gives you immense leverage, right, in this world of AI, if you are able to develop a pool like that. So that can be doable, that can be done, that is doable, and that can be done. Obviously, it needs kind of a few different people from few different perspectives coming together to create that kind of a pool. Well, that's all for today. Thanks for watching.